Hello, so today we are going to have a look at earthquakes and we're going to do this in a little bit more detail so that we're ready and prepared for our case studies, which will be contrasting two different earthquakes. So the focus of this video is going to be what is an earthquake, how do we measure them, what are the key effects of earthquakes, and how do we respond to an earthquake. So to start off, what is an earthquake? This is something we've looked at before. They are just vibrations caused by Earth's movement at the plate margins, and they occur at all of the fault lines and all of the plate margins. So they occur at your destructive, your constructive, your conservative, and also at your collision boundaries. So you can see here in this diagram where the focus of an earthquake is, and this is deep beneath the Earth's crust. This is where there has been the movement in the Earth's crust. The seismic waves produced by the earthquake start at the focus, and this is the focus. Now, directly above the focus on the Earth's surface is what we call the epicenter. And the closer you are to the epicenter, the stronger the magnitude of the earthquake. Make sure you've learnt these key terms. The focus is the point where there is movement in the Earth's crust, the epicenter is directly above the focus on the Earth's surface, and the seismic waves start at the focus. And you can see where the epicenter is located and how the magnitude reduces the further away from the epicenter you are. Now to recap and just to remind yourselves, earthquakes are more violent at a destructive and a conservative plate margin. Now this is because over time the stress will build up at these types of plate margin where the plates are colliding or pushing against each other, and when it is suddenly overcome, the plate will move and shift and that energy will be released. There are two main ways to measure how strong an earthquake is, and the first one we are going to look at is the Richter scale, and this is the one that you might be most familiar with. The Richter scale is measured on a seismometer, and this records the earthquake's magnitude, and it looks a little bit like this. The Richter scale is logarithmic, and that sounds like quite a complicated key term, but it just means that a magnitude 7 earthquake is 10 times more powerful than a magnitude 6, a magnitude 6 is 10 times more powerful than a magnitude 5, and so on. Earthquakes that are larger than a magnitude of around 5 are likely to cause structural damage to buildings. Structural damage can be anything ranging from cracks in the walls, a sagging roof, anything that might impact on the safety of your home. The largest recorded earthquake on the Richter scale was a 9.5 magnitude, so extremely high, and this was in 1960 in Chile. The next method of measuring an earthquake is the Mercalli scale, and this scale measures how much damage is caused by the earthquake based on observation, so using your eyes, and there is a scale between 1 and 12 for this. 1 is the least destruction and 12 is the most destruction. So you don't need to know these off by heart, so let's just run through these super quickly. Number 1 can only be detected by instruments. These are the types that you're going to get in the UK, the earthquakes that you would never even know have happened. 2 is very feeble, only really noticed by people at rest, and 3 is very slight, so felt by people at rest, a little bit like a lorry going past. 4 is moderate, so generally perceptible by people that are moving, loose objects might be disturbed. 5 is rather strong, so dishes might be broken, bells might be rung, people might be woken up. 6 is a very strong earthquake felt by everyone. Some people might be frightened, there might be slight damage, some plaster might be cracked on the walls. Magnitude of 7 is very strong, noticed by people driving in their cars, damage to poor construction as well. For magnitude 8, it's very destructive, chimneys might fall off, there'll be a lot of damage and substantial damage to buildings, heavy furniture might be overturned. 9 is where there's great damage to substantial structures, that could be bridges, the ground will be cracked, pipes might be broken, that can also cause fires. Magnitude of 10 is disastrous, many buildings are destroyed. 11 is very disastrous, there are few structures left standing, and finally we have a magnitude of 12, which is catastrophic and there is total destruction. The United States Geological Survey, or USGS, have an excellent website where you can see all of the earthquakes that have been recorded around the world using the Richter scale, and you can identify where they are, how strong they are, and also you can explore some of those effects. In geography, there are causes, so earthquakes, then there are effects, what are the knock-on effects or impacts of an earthquake, and then we have responses. How do we respond to that problem or that event? So we have covered the cause, which is the earthquake, and how and why they occur, and now we're going to focus on the effects of that earthquake. And effects for any type of hazard, these include earthquakes, volcanoes, atmospheric hazards like hurricanes. These are all split into primary effects and secondary effects. Primary effects occur immediately as the event happens, and secondary effects are the subsequent or after effects of the earthquake or the event. So remember, this is not just applicable to earthquakes, this is for any type of hazard that you might study. So the primary effects that we're going to start off with, things that happen immediately as the earthquake occurs. 3 examples of primary effects are buildings collapsing, roads and bridges being destroyed, and death and injuries to individuals. These deaths and injuries will have been caused by something that occurred during the event, for example being injured by a falling building. Secondary effects are as we've said, the subsequent effects after the earthquake has occurred. So, to start off with, fires caused by broken gas mains or electrical fires are very common after earthquakes, and these are a secondary effect as they happen after the main event. Tidal waves and tsunamis are also a secondary effect of an earthquake. When they occur underneath the ocean, this can cause a tsunami. Landslides or avalanches can be triggered by an earthquake, and this is a secondary effect, which can then cause further destruction and devastation to areas, communities, and homes. Shops and businesses are often really badly affected after an earthquake occurs, and they can lose quite a lot of money. Tourism may also reduce because people don't want to visit an area that has been devastated by an earthquake. After an earthquake occurs, it's very difficult for people to trade with that area because things like roads might be blocked, it might be difficult to get airplanes in, and different types of transport. Disease and famine are often a secondary effect of an earthquake for many reasons. The first one is a bit like with trade, where it's very difficult to bring in food and goods for people to actually be able to live off. And disease can often be spread quite quickly when people are vulnerable and living in temporary shelters and unable to move back home. And this can often cause problems, especially if there's not good enough sanitation, clean water, and that is often a secondary effect that we will see in a low-income country. Death and injuries can also be classified as secondary effect, and this is if it occurs after the main event. So if they are injured by the fires or perhaps by the landslide or the avalanche or tsunami, this can also be mental health related, so people that are traumatized after the event. And finally, homelessness is a very common secondary effect of a tectonic hazard. When people's homes are destroyed, buildings are collapsed, people don't have anywhere to live. So we've covered the cause, the effect, and now we're going to look at how we respond to tectonic hazards or hazards in general. So short-term or immediate responses are the response that we give to an event in the hours, days, and weeks immediately after a disaster. So, for example, with an earthquake, the short-term or immediate response will be mainly involving search and rescue efforts and also helping those that are injured. The long-term responses are those that continue for months and years after a disaster. This can involve things like rebuilding damaged or destroyed houses, schools, hospitals, buildings, bridges, any other infrastructure. Kickstarting the local economy is also a long-term response, developing opportunities for the economy to recover, sometimes resettling local people, things like restoring utilities such as water, electric and gas, anything that takes a little bit longer, so anything in the months and years after the earthquake or the disaster has occurred. So you should now be feeling quite confident about the following key terms that we have covered in this video. The focus, the epicenter of an earthquake, seismic waves, Richter scale and the Mercalli scale, primary versus secondary effects and how they differ, short and long-term responses and how they are different. There are more, which you can go back and check through, but just make sure that you'll feel really confident about what these are and what they mean. It is essential you know these and feel really comfortable with using them in paragraphs and sentences because you will need them when you come to your case studies.